Now, in this lecture, we will discuss memory management requirement. In the last class, the virtual memory concept, I have explained completely by taking a single large program. Now, if this is a main memory and if this is a secondary memory, that large program is not fitted into the main memory. So, part of the program is brought into the main memory and the remaining program is stored in the secondary memory. Now, after completing the execution of the program, this page is swapped with the new page of the secondary storage, new page of the program. That is nothing but what this we the program, the page which is in the main memory is copied into the secondary memory, and the new page from the secondary memory is brought into the main memory. This swapping or this transferring the program and instruction data from the secondary memory to the main memory is done automatically by the management routines which are part of the OS. So here there is nothing but what OS is taking care of this transferring the data and the program between the memory and the main memory and the secondary memory. Now these routines are stored in the, now if we take the complete, this is a virtual address space. So divided into parts. So this is a called the system space. In this operating system routines are loaded or assembled. Now the remaining space is called the user space. Now application programs are stored in this. Now, in this, if the single application program is there, that is the complete space is called the one user space. If the multiple user spaces are there, then that time this is space will be divided into the multiple user, and each user will use the each space. Now here MMU, already in the last lecture we studied that MMU will translate the virtual address into the physical address. By how it is translating? By taking the content of the base register, page table base register, adding with the virtual address, then it will generate the physical address. Now, if we try to change the page table base register content, then it will switch from one user to the other user. Now, here many users are there, including the system space, and multiple user spaces are there. How to switch from one user to another user means what? By changing the content of the base register, automatically operating system will change the one space to the another space. But at any given time, the page table base register can point to one page table only. Now each user space is having its own page table, but at any given time, only one page table will be pointed by the page table base register. So the meaning is what? Pages belong to only one space are accessible in at any given time. So this is done by the operating system. So this is the management routines will take care of this. Now the second one is what? If the multiple independent user programs coexist in the main memory, and how to ensure that one program does not modify or destroy the another user program. Means now here processor usually has to has two states of operation. One is a supervisor state and another one is a user state. Now, operating system routines are executed in the supervisor state and the user programs are executed in the user state. Now, certain privileged instructions can't be executed in the user state. Now, what are privileged instructions? We studied in the interrupts. The instructions which executes only in the supervisor state is called the privileged instruction. Now, these privileged instructions include the one which change the page table base register. Now, if we try to change the base table register content, then immediately it will switch from one user to the another user space. Now, this is nothing but what? Protection. This is the protection. So, protection is also done by the OS. Now, coming to the next one, sharing. This is called the sharing. That is also done by the OS. How the sharing is done, we will see here. One application program to need to access a few pages of the another application program. Then the operating system can arrange this by causing these pages to appear in both spaces. The shared pages will therefore have entries in both different page tables. Now, instead of copying the pages in two program spaces, so it will share the one application program content to the another application program. So by doing that, the memory space can be reduced. Now the control bits in each table entry can be set to control the access privilege granted to each program. For example, one program may be allowed to read and write a given page, and while the other program may given only read access. Now here this is about the sharing. So now operating system, the memory management will take care of the relocation, protection and sharing. Now this is about the memory management requirement.